Right. So we were talking about so different approaches that we have. If before always on, right? So so log shipping, database mirroring, SQL failover, clustering. So these are all used to so maintain that high availability and disaster recovery solutions, right? So what we have the drawback and why we came up with or why Microsoft came up with always on, right? So there are a certain drawbacks, right? So let's say just try a comparison between between these, like, so that we'll understand why we even require a mm, why we even require always on, right? For example, log shipping. So log shipping, uh so you can configure a database level, right? So you'll have to configure at the database level, and which is used for the disaster recovery for DR, right? So there is no high availability for log shipping, right? So you cannot use for log shipping. So you'll have to use for disaster. You'll have to use database level, right? And no automatic failover happens, right? So if there is a database level, no automatic failover, right? Right. So at the database level, so cannot have an automatic failover in the log shipping. No operations at the secondary, right? Secondary server you use as a standby. That's it, right? So secondary server we use as a standby server, right? So what else we have? In log shipping, yeah, let it be, right? So we might have few, but the main disadvantage of using log shipping is people are using, but still, like, so it is only 10 for disaster recovery. There is no high availability feature involved, right? So in mirroring, so mirroring, uh, we have a high availability and DR as well, right? So either high availability DR. Let's say, for example, I'll consider that high availability. High availability DR with log shipping, right? So you'll have to use two technologies, two features to maintain HADR solution. To maintain HADR solution, right? So you'll have to have always log shipping and database mirroring to maintain the HADR solution, right? So and a single database involved, right? Single database involved. Only one database that you can configure, database mirroring, right? So if you have 100 databases, you'll have to configure a database mirroring 100 databases, and then 100 configurations you'll have to perform, right? So to perform the database mirroring for the databases, right? So single database which involves. So we do have an automatic failover, right? So and we all know, so always on is a little extension, or always on is an extension to the database mirroring. So database mirroring, we do have a drawback. Drawback is nothing but a single database configuration, and we'll have to use HADR solution with log shipping, right? So what else. No operations as secondary. So no operations at secondary. So there is no, we cannot, there is no operations at the secondary server, right? So, yeah, so let it be. And clustering, FCI, failover clustering. So what are the failover clustering features, right? Used for HA, right? So plus DR using mirroring or log shipping, right? So mirroring or log shipping, people are use HA, HADR to meet the HADR solution, right? So even FCI alone is a high availability feature, right? So we use this DR using mirroring and log shipping, right? So we are also using two technologies, two features to maintain the HADR solution, right? So two features to maintain HADR solution. Okay. Mm. So it's a single point of failure disk, right? So they have a shared disk, and if the shared disk is corrupted or shared disk is gone, the entire cluster would go down, SQL cluster, right? So it's a single point of failure. And if it is a single point of failure, then maybe you'll have to bring the DR online, but automatic failure would not happen. That's a different story. But yeah, so single point of failure. It is a instance level high availability, right? It is instance level high availability. The entire instance, it will either move or move it forward or move it back, right? So the entire instance level high availability it maintains, right? So it uses the I'm just making a note of so the behavior, the points that we have in the uh, in all these three, right? So drawback is the single point of failure, right? So we use okay, so we use virtual network name to redirect the application traffic connections whenever there is a failover. So whenever there is a failover, we use virtual network name that will redirect, that will take care of automatic failover of your cluster, of your application. Sorry. So what automatic failover would happen, and application would connect wherever primary is using virtual network name, right? So is this connects to the virtual network name. Even single point of failure, anything like even virtual network name is down, right? If virtual network name is down, that is also single point of failure. That is anywhere. Even today, always on, like if the listener is down, that is a single point of failure. Right? Yeah, that's okay. That's a different concept. But yeah, virtual network name we use to redirect the application connection string. So application connectivity using database mirroring. So you'll have to use the server name, comma, failover partner. Failover partner, right? So server name, comma, failover partner that you'll have to define, right? So server name, database mirroring involves two servers. One is the primary server or principal server. Second one is the mirror server, right? So you'll have to provide the server name and the failover partner name so that whenever there is an issue to this server, the failover would trigger and connects to the partner server, right? So this is the one, right? But we have a DR using log shipping, for example. If we use the log shipping, if entire disaster happens, right? So DR you will bring online and you'll have to change the connection parameters, right? You'll have to change the connection parameters. Okay. Uh, if we switch to DR, need to change the connection string, right? Need to change the connection string because that server would not be able to mention in the connection strings, connection properties, right? So if we have some issues at the high availability, let's say you have two servers, one is principal, one is mirror, say third one is DR using the log shipping, right? If these two servers have some issue, right? So these two are gone and you'll have to bring it online manually, the log shipping server, and use this log shipping secondary server to you'll have to bring it online. And once it is brought online, then you'll have to change this connection string pointing to the application. This server name pointing to the application. So in the application, you'll have to point this server. In the application connection string, you'll have to define this server to connect. Right? For log shipping, you don't have a automatic redirect. If you use this primary and standby server, primary and secondary server, if primary disconnects and you'll have to use the secondary server name manually, right? You'll have to define the secondary server name or we'll have to manually enter the secondary server name or manually change the connection string if we do a failover from one server to another server. Let's say this is gone, primary is not available, then you can make secondary as primary and you'll have to change the connection string pointing to the application. So application connection string, you'll have to change pointing to the DR secondary, right? So log shipping secondary. And this one, whatever, like failover clustering. So automatic redirect happens, right? Application connectivity, it uses that virtual network name, right? It uses the virtual network name to connect the application. So it maintains that automatic, it maintains the automatic failover. So you will have an automatic failover if one node is down. Let's say what if entire disk is down, right? So if there is no and I mean, if the entire storage is down, that is the single point of failure, right? If you want to switch it back to the DR, right? If you want to switch the, I mean, if you want to bring the DR online, then that way you'll have to change the connection string again for the high availability for clustering, right? You'll have to change the connection string again to pointing to the cluster, right? So these are all considerations, right? So we have different drawbacks, right? So what is the drawback that if we talk high level, log shipping, it is used for only the disaster recovery. There is no high availability concept, and we cannot use because the data will not always be synced, right? How log shipping works, that we know, right? So how log shipping works, right? Suppose if I take log shipping. So it's not a continuous synchronization, right? Log shipping, it takes the backup from primary, right? Whatever backup jobs that we configured, whatever the schedule that we configured, every frequency, the log backups will ship to the secondary, and log backups will ship to the secondary and it will restore on the secondary, right? So it will restore on the secondary. So it is not a continuous sync. Even if something goes wrong on the primary, you will have a at least at least 10 minutes, or even at least 5 minutes to 10 minutes, or even 15 minutes, whatever jobs that we configured, you will have a data loss if primary is down, right? uh okay, 1 second. Can we have another storage as a backup in FCI? Another storage as a backup, what do you mean? So we can have another storage, but what about the master and system database files that we have, right? So system database files, everything stored in the same disk. If the disk itself is not coming online, or if you are not able to bring the data disk online, right? So you can restore the databases, right? But whatever, so the master database files exist, so you cannot recover those. If you cannot recover the master database files exist in the storage, so even if you have the, so backup files, you would not be able to restore, right? So you will have to do a different methods and all, like you will have to try to bring the SQL online, but it would be tedious and it takes very long. You can have this very different, so storage altogether, right? So you cannot have the backup. Maybe if you have this storage level replication or anything, maybe the same storage will be replicated somewhere, and you can plug out and plug in here to see if that can be possible. System database backups, that is a different discussion altogether, but system databases backup we can take, except MDB, right? Master model MSDB, we can take the backup and you can restore. But again, so if when you will restore, right? So at least you would be able to connect, or you'll have to follow a different methods to restore. Again, it will have a high RPO and RTO. You can have the system database backups, right? For log shipping, so you'll have to have you will have high RTO and recovery point out RPO, right? The reason recovery time, because if primary is down, so everything is manual. right? Bringing the secondary is manual, and changing the connection string is manual, and redirecting application, everything is manual, right? The time it takes to recover would be more, right? And recovery point objective, like let's say for example, right? So let's say for example, we have three jobs in always on, in sorry, log shipping. One is backup, copy, and then restore. Backup, copy, and restore. And whatever the frequency that we take, right? So that frequency, let's say for example, 5 minutes or 15 minutes, the overall process it takes to restore, right? So if it takes 15 minutes to restore, right? Whatever the last restore, let's say this 15 minutes could be the potential data loss. Could be. It can be more than that, right? So this could be the potential recovery, potential data loss, right? So you'll have the recovery RPO would be high, right? So if you use the log shipping, what if you use the database mirroring? So database mirroring, let's say if it is if we are maintaining the high availability using witness server, let's say, and you'll have the primary and the secondary, primary and the mirror, principal or and sorry, principal and yeah, mirror. With the help of witness, you will have the high availability. And here, here also to maintain the high availability, we require another server. I'll tell you why we need another server in a bit. But so to maintain the high availability, we need another server, right? So to maintain the disaster recovery, we require another technology altogether, another feature that is either log shipping or even whatever replication or something that we can figure. So you'll have to have another feature, right? So another feature for high availability and disaster recovery, and to maintain the high availability, we require another server altogether. So if we have only two, it doesn't work, high availability. You'll have to maintain the another server that is called witness to maintain the high availability for mirroring, right? And if primary is down, with the help of witness, it will trigger a failover to mirror server. So mirror server will become primary, right? So then automatic redirect happens using this two parameters, using this parameters, right? Server name and the failover partner. So application will redirect. Well and good, right? So if these two are down, then this will be manually needs to change. So how about recovery? RPO or RTO, right? If we have HA, then so we will have this 99% availability, right? So almost available. So we'll have the less RPO and RTO. If we have HA, RPO, RTO would be minimal, would be less, right? So RPO, RTO would be less. If HA is gone, right? So if you want to bring it to the DR or the different node or DR server, if we need to, so if we need DR, right? The RTO, RPO would be much more higher. Higher. The reason it is high, okay, so the reason it is high, because if primary is down, I mean, if HA is down, right, you'll have to bring the secondary online, right? How you will have to configure, you'll have to use log shipping, for example, right? The same concept. If it is log shipping, it will take backup, copy, and restore. So the amount of time it takes for these three is the matter, right? So you will have the, so you will have high recovery time, right? So you'll have to do it manually, and point recovery point objective, right? So how much data potential data loss would be depending on the jobs that we configured, and minimum it could be 15 minutes, right? If that is the case, so see, like, just if you are taking as a 15 minutes, it might be less. 15 minutes as a word, it might be less. But so with this 15 minutes, just assume that if it is a huge transaction, let's say, for example, it is kind of, so any e-commerce, right? Let's say, for example, Amazon, or you can consider that Walmart, right? Or Flipkart, like any e-commerce that you take, right? If you take the e-commerce and the 15 minutes is a downtime, or 15 minutes, uh, you would not be able to bring it online, right? So understand like how much data loss it would be, and understand how much, sorry, how much revenue loss to the company. And it's a very huge, right? So you might lose the customer as well, right? So they cannot keep waiting for you to bring it online, right? So if they cannot, they'll go somewhere else, right? They'll go somewhere else and they'll go and purchase whatever they need, right? So that is where the impact, right? So that is the impact that we can consider. This is for database mirroring. If it is, one sec. If it is FCI, failover cluster, right? So failover cluster, you will, so recovery point and recovery time. So if we have the storage, everything available, if we have an issue on one server, the recovery time and recovery point would be good, right? So if we have the cluster, then you'll have the recovery time and recovery, you can consider that 99% or 90%, whatever it is. You will have, if it is cluster, if the cluster is available or stable. Let's say if storage is stable, I'll mention that. Stable. So you'll have this 90%, you'll maintain this recovery point and recovery time, right? So you can mention that 99 as well, because if the storage is available, the failover only the matter, right? So if failover happens, then your application would be able to recover, would be able to connect, right? So it would not take longer to get the data. If storage is not available, let's say storage failure. Storage is failed. There is a failure in the storage. Then what can be the recovery time and the recovery object, right? Someone asked in the chat, right? Like, so we can have the backup, right? So we can have the system database as backup to restore, or you can have the standby storage. It can be anything, right? So like how much time it takes for you to perform all this, right? It is a tedious and it takes hours together and it can take longer, right? So the recovery time much more higher than other two technologies. Mirroring, log shipping. Okay, so mirroring or log shipping, RPO and RTO would be much more higher than log shipping and mirroring. The reason, if storage is failed, how you'll bring it, right? So what time it will take, right? So the storage can be any issues, right? The plugin between storage and the hardware, the system might be disconnected, or storage itself is corrupted, right? It is going offline. We have to engage storage team and we'll have to get it so fixed. Then the storage will be plugging back to the hardware, right? So that can be a tedious. It can take longer to maintain this recovery. I mean, to have this recovery time. So recovery point objective, right? So how much data can we will have loss? So it can be huge, right? So for example, let's say you have clustering with mirroring option or clustering with log shipping, whatever. So you will have to have, right? So if primary is down, the cluster is down, right? So if primary is completely down, and again, so you'll have to maintain, I mean, you'll have to bring the secondary on, secondary as in DR online. That is a manual that also take longer time. And this one, if I take, right? So we were talking about mirroring features, right? High safety and high performance. High performance in database mirroring, right? So high safety and even high safety, there are two things: high safety with automatic failover and high safety without automatic failover. Can anyone tell me what is the difference between these two? What is high safety and what is high performance in database mirroring that we all know?
Yeah, high safety, like it's a synchronous mode where I mean, there won't be any loss of data.
Mhm.
And coming to high performance, there might be chances of data loss, like if there is any issue with the uh, primary. I mean, if the data is not committed at the primary or like,
So you
I mean,
mentioned this
actual
is
data
synchronous. What is this?
asynchronous.
So we'll have to configure using async high performance, right? So if there is,
Mhm.
if we configure high performance, so we will have to have a data loss. That's what you're telling.
Yeah.
Mm,
Uh,
mm.
no, I mean, not compulsory, but just, I mean, like, um,
Potential, right? Whatever it is.
yeah, because
Mm,
everything is getting committed at the primary,
mm.
and whatever is committed at the primary or something happened to that disk or something like, then chances are there of data loss, but otherwise, no.
Correct. Yeah, I agree. So high safety, you can use this synchronous with automatic failover and synchronous without with manual failover as well, right? So if we configure using cluster with high performance, you can configure using high performance as well, right? So there is no doubt at all, right? You can configure using high performance as well. And using high performance, we can configure um, like in both, we can use to configure database mirroring between the cluster and the standby server or cluster or the secondary server, but automatic failure would not happen in the cluster environment. So automatic failover to the DR would not be there. Even till today to always on. So we don't have automatic failover, that we will talk later. Right? So if you configure this, if this is down, so you will have this more time to recover, right? RTO would be more. RPO can be maintained. RPO less, right? So what RPO less, the reason your entire data will be in sync with the DR, right? So that is the reason we always prefer, like suppose if it is what we call, like if it is clustering, better to use a mirroring as a DR so that you will maintain the data, exact replica of your data, right? Exact replica of your data. But let's take another scenario, right? Let's say, for example, let's say you have a cluster environment here, primary and secondary, right? So you have a cluster environment, whatever it is, and you have it as a database mirroring, cluster failover, cluster instance, right? Primary, nodes 1, node 2, right? We have two nodes here. We use this as a mirroring. So here we maintain the instance level high availability, right? Instance level, right? If one instance is down, so the entire instance or the services will move to the next node, right? So it will bring it online. So you will have this next node available for your connection string. And mirroring whatever databases that we have it here. Let's say, for example, you have 3 databases. Let's consider. So if failover cluster, you will, one second. Right. So in failover cluster, you'll have two nodes, node 1 and node 2, and it maintains the high availability for your database, for your entire instance level, right? So this one node, this one 3 databases, let's say you have, and you have system databases as well, right? Including model, MSDB, TempDB, master, everything you have. Everything you have, right? So, and you have something, system configurations and all. System configuration, sp underscore configure, like whatever memory configuration. So whatever system configuration, everything you will have it here, right? But here in the mirroring, you can maintain only the whatever databases which are configured for database mirroring. Let's say out of these 3, you have the database mirroring for only 2, for example. Let's take scenario. And the other database would not be able to recover, right? So we would not be able to other databases, including your including system databases, you would not be able to recover, right? So that is the another uh, key point, right? So where if we use the failover cluster and the database mirroring concept, right? And another example, let's say you have jobs, whatever jobs which are running on failover cluster. So the jobs will not be replicated. So you will have to create the jobs on the mirror server, right? So you'll have to jobs on the create jobs on the mirror server. So whatever it is, you'll have to accept the databases which are configured for database mirroring would not be replicated. Except the databases which are configured for database mirroring would not be none of the other areas, other so properties will be replicated to the database mirroring, right? So That's what, like, so these are the disadvantages. If the entire cluster is down, this is the overall cluster. If this is down, then you'll have to bring it online. And that too, you can bring only a couple of databases. And if you're talking about the recovery point objective in this situation would be less or very less. The reason you will have the data copy here as in mirror server, because if you configure that high safety, the term itself is telling, right? It is safe, right? So this is safety. This is safe. Like even if primary is down, so you will not have a data loss, right? So you will not have a data loss. But what if you configure high performance? We will talk about why we call high safety and why we call high performance in a later. I'll add this while talking about the always on, so always on synchronous or asynchronous. So you can consider that it is as a synchronous always on, and this is an asynchronous, right? What Anu was telling before. So the same synchronous and asynchronous and high performance and high safety, right? So with this, if you configure with high safety, you will not have any data loss. But if you have this high performance, you'll have a potential data loss, right? So it all depends on how much data is not yet replicated on the secondary, right? So these are all the concept till always on, right? With all these considerations, with all these considerations, Microsoft announced a feature called always on high availability, right? So Microsoft announced a feature called always on high availability, and we will talk that. Right. So what is high availability? What is always on, right? So what is always on and how that works, right? So I'll just make a note so that I will show that like whatever PPT that we have later, right? So let's say till today we were talking about the high availability in disaster recovery and only one feature wouldn't support, right? Till today. Database mirroring, only database mirroring you can configure, but either you can configure DR or you can configure either HA, right? Log shipping, it is always log shipping is a DR, right? You cannot have a high availability if one server is down, and you'll have to have more recovery time. And clustering, we always use as a high availability feature. We can configure DR using database mirroring on a different server. And whereas if you want to connect, you'll have to switch the connection string, right? Pointing to the database mirroring. To all these concepts, I mean, all these uh, drawbacks or lack of, so high availability and disaster recovery solutions, Microsoft has announced a concept called always on in SQL 2020, 2012, 20, sorry, 2012. So always on, I would say, is an extension to the database mirroring. Right? So always on, I would say, is an extension to the database mirroring, right? Extension to the database mirroring. So it inherits the same concepts of database mirroring and always on has introduced, right? So that is the reason I mentioned, or even Microsoft mentioned, this is a just a enhancement for database mirroring. And you will have a single solution for HRDR, high availability and disaster recovery. You don't need to have multiple features to have this HADR concept. You'll have single solution for HADR. Single solution, right? So you'll have a single solution for HADR. And you can have multiple secondaries. One primary plus 4 secondaries, right? This is up to 2014, right? There is some changes in the 2014, 2016 and all. So we will talk that later. But the concept, like we are just talking about the concepts, right? So you will have a multiple secondary servers, right? To maintain the dead multiple secondaries to maintain the DB copy, database copy. Right? So multiple secondaries to maintain the database copy, right? So you can use the secondaries for certain operations, for a few certain operations. We will talk what are the operations that we use, right? So we use secondary mainly for read. Uh, okay, that's fine. We'll say that. We use secondaries for certain operations. Let's say read, or you can take the backups. Okay, I'll just mention that. We will talk that later. Read, or you can read this. You can read the secondary. You can take backups, right? You can use DBCC jobs, DBCC check DB, for example. So that also can be run on the secondaries, right? While we are discussing, if you remember or if you know any points, you can also tell me, right? So I will add. This is just, so wanted to understand what is your, um, so idea on always on or any features that it matters, right? If you have any points, feel free to pitch in and tell me. That should be fine. Okay. So use secondary for certain operations, right? So you can use the for read purpose. This is the main advantage. And backups you can take, and you can run DBCC check DB to validate the consistency, right? To maintain to check the database consistency. If there is any corruption or anything, that we will have this on secondary. It suppose automatic failover, right? So whatever, like, so servers, it suppose automatic failover, right? So you'll have the 5 replicas. Out of 5, you will not have every replica automatic failover. You will have the certain limit. We will discuss that later, but automatic failover is supported.
Automatic as well as manual both, right?
Yeah, manual anyway is supported. Automatic is supported for automatic. I'll mention that manual failover, right? Both it supports, right? So always on, it supports automatic failover and application connectivity. It redirects application connectivity using concept listener, right? So wherever it is, like either it is a primary HA or DR, like wherever it is, you will have the same listener, and to maintain the redirect part, right? You will have the application redirect using the listener, right? So you'll not have to change the listener name if you configure the DR as well, right? So you will have the recovery time objective, recovery point objective, you will maintain very high. So books online says that 5 nines, 99.999. So you will maintain the high availability. For example, that there is a, so in this also we have terms and conditions, right? So if we have the high availability with automatic failover, or if you have the so automatic failover configured, or even I would say like so synchronization configured, synchronous configured, then it maintains. What if it is asynchronous? What if you want to move it to a DR, right? So then that is another story, like you will not maintain that. But at least you will have this 99.999, the reason that we have. So in always on, let's say you have always on here. Let's say 1, 2, 3, 4. Just consider. So you'll have this primary, you have secondary 1, you have secondary 2, and you have secondary 3, right? So primary and secondary we can configure, and S2. Up to this, you can configure automatic failover. For example, let's say primary, automatic failover, secondary, automatic failover, second, another secondary. This server you can use as a DR. This you can use as a DR. So what happens? The reason that we mentioned, or Microsoft mentioned that 99.99, let's say this is gone. If this is gone, automatic failover to this, right? Even this is gone, automatic failover to this, right? So at least you will have multiple servers to maintain the automatic failover before the entire cluster is down, right? You will have the automatic failover configured to multiple servers. So at least one server is available, then it will go ahead and failover, right? So if this you consider DR, like this is where you will have that data loss, right? So let's say this is a different whatever, like so we will talk that subnet and all later, but let's say this is a different region or different server where you use for DR, right? So if you use, if the entire cluster is down, right, if the entire cluster is down, then only you will have to have this one, right? So DR, you can bring DR online. If all synchronous replicas are down, then you'll have to bring it online. So that is the reason RTO and RPO would be higher in terms of in always on, right? um what we have, so solution, like so you'll have this automatic failure. What is the application connectivity and recovery time objective? What else? It is a
Um,
mhm,
One doubt, Chandu.
yes.
Like as you said, like the third server, secondary server.
Mm.
So we can't have that as in the same cluster with asynchronous mode. Not possible, right?
Same cluster, it should be in the same cluster.
But
We
just
will
now you said.
talk about distributed ASA and all later, but this is the same cluster. Within the cluster, you will have this. This cannot be in a different cluster altogether. It will be in a different region or different, so subnet or different uh, location, but it should be in the same cluster. It cannot be in the different cluster,
Okay.
right? It will be in the same cluster. Mm, okay, so thanks for that. This requires a cluster to maintain, to have the always on, right? So I have not mentioned, but even we require a cluster for the, right? So what is these platforms uses, right? So this use, what is that? Hmm, what is that? It's gone. Okay. So this is a standalone, right? Standalone as in everything will be maintained within the server, right? So there is no cluster or there is no, so nothing involved, right? So it is a standalone that we configure. So database mirroring also a standalone. Database mirroring also a standalone servers, right? So you'll have two servers, two SQL instances you'll have to install, and it will be a standalone without depending on the Windows cluster, right? So without depending on the Windows. So high availability failover cluster is require a Windows cluster. So I'll talk like a high level what is the cluster and all. But yeah, so we require a Windows cluster. But I will discuss detail why Windows cluster is required, right? So you will have to have a Windows cluster for the SQL failover cluster instance. The same concept for data always on availability group, right? So always on availability group, the same concept, we require a cluster to have always on feature enable, right? Right. So what else I missed here? Suppose automatic failover, application connectivity, cluster to have the always on, and we have different features as well, right? Like say for example, we will talk about that, and different features that we have to maintain the database available. Let's say for example, automatic page repair. I mean, we will talk that. I just wanted to mention this automatic page repair. If any of the page is corrupted on primary, that will be repaired by taking the page from secondary, right? So these are all just a features within the always on. We will talk that as a separate discussion. Just for your information, we will have that, right? So and you can configure always on in single subnet or multiple subnet, right? Subnet is nothing but a network is divided into multiple groups. For example, a network range, let's say, for example, take locations, right? So from India to the USA, right? So you have two different um, regions, right? So India to USA. So you cannot have only one network config connection. So network is basically a physical fiber net, right? So you'll have to connect the locations and all, right? So what if you have only single network and if it is connected till the USA, right? So you will have that only one connection, one network. So instead, what you have a hub here, let's say for example, hub, or you can consider that router in our in our terminology network, you'll have a router, right? Where you'll have the connection and you'll connect here, and this will be route to a different location. Where you'll have the connection, it will route to a different uh, system or a different port, whatever. So this also, the subnet also, the entire network will be divided into multiple parts. This part will be managed by one hub, for example, and the remaining part will be managed or maintained by another hub, right? So, but all will be connected in internally, right? So, but only thing, it will be divided, separated by another network range, right? It is just a divide, subnet, right? Sub is nothing but subdivide the network into multiple parts, right? So that is the reason if you have this it is easy to maintain or easy to handle the network range. Let's say, for example, the range for network is, let's say, for example, 255.255.255.0/24, for example, let's say. And if it maintains 170 IPs, just an example, or let's consider that it maintains a 24 IPs, just for our understanding. Sorry. So if you have 24 IPs, if it is a single subnet, the entire range will be 24 only. What if it divides with another network range? Let's say, for example, 255, 255, 252 divided by 0 divided by oblique 4, 24. So you will have another 24 with this subnet. So the difference is this range, right? If I open that my command prompt, and if I use this, and you'll have this subnet, right? What is the range my subnet would be, right? So what is the subnet that I maintain, that I have? This one, right? So you will have this is the subnet range, right? So the same thing, if I go here and take that IP config, right? This is another subnet 255, 255, 240.0, right? So this is the subnet that we define, right? So likewise that we'll have to have this subnet will be defined. So if you have multiple subnets, the network range will be increased, right? Suppose let's say you have this entire range in a single subnet, then how many IPs will be supported? Only 24. Let's say this is just a word, right? I don't think it is limited to 24. You can have more than that. But yeah, I'm not going into networking. Let's see, you have this single subnet. If it is single subnet, you will restrict the IPs to limited. So let's say, for example, 24. And if you divide this into multiple groups or multiple subnets, then you will have 48, right? 24 plus another 24 for another subnet range, right? So you will have that you'll have that more IPs if you have different subnets altogether, right? So this is the subnet range that we have, right? You can configure a single subnet or you can configure multi-subnet. Now, if I configure always on with multi-subnet, what will happen? You will have to have two IPs for this. One from one subnet, another one from another subnet. We will talk that multi-subnet later, but just for your information to add these points, I'm just using these keywords, right? So we can have single or multiple IPs. IPs for the listener, right? You can have single or where I have don't place, no place. Okay, so you can have single or multiple IPs. Single or multiple IPs that you can have, right? So either it is a single subnet or it depends on single subnet or multiple subnet that we have. And what we have, say, extended single solution, multiple use, secondary supported automatic. Okay, it doesn't require a shared storage. Local storage It maintains the local storage. We don't require a shared storage like always like SQL failover clustering. So we don't require a we don't require a shared storage, right? Now, so easy to perform some maintenance activity, easy for maintenance. So easy for maintenance. The reason for easy to maintenance, because you will have the secondaries. So you'll have the secondaries, um, secondary replicas to uh, perform some maintenance activities, right? So secondary as in like you can apply some patches on the secondary, or you can apply so Windows patches or SQL patches or anything it matters, you can do it on the secondary. So upgrade also. So everything will be done on the secondary, right? So if it comes to other technologies that we have, right? Suppose let's say if you want to upgrade database mirroring, so still you can upgrade database mirroring on the secondary. There is no issue, right? So database mirroring, you can upgrade on the secondary, and the log shipping, everything will be that can be done, right? So there is no issue. But what if secondary, then it is a single point of failure. Let's say what I mean, this is your primary, this is your secondary. Let's say for database mirroring, whatever like witness server that you have to maintain the high availability, and you'll have to maintain this. You'll have to perform some maintenance on this. Let's say installation, patching, upgrade, whatever that we are doing. So you'll have to apply this. Until you upgrade or until you apply the patch, this would not be accessible. This would not be available, right? Now, what will happen if something goes wrong to here? Where it goes to? If something goes wrong, the failure would not happen because this will be disconnected. So the secondary would not be available during this maintenance. Then it is a failure. But in always on, this is for database mirroring and log shipping. What about the clustering? If it is a SQL failover cluster, if it is a SQL failover cluster, so if it is a SQL failover cluster, you'll have the primary, you'll have the node, multiple nodes, right? Primary and secondary nodes. Definitely, you can do any maintenance on the secondary. So secondaries also in the failover cluster, you can have multiple. So there is no, so you'll have multiple SQL failover clustering instances or nodes to be added, but all will be on a standby. So none of these will be used until that you need a automatic failover, or until you have some issues on the primary, automatic failover would not trigger, right? Automatic failover would not trigger, right? So what we were talking, yeah. So it has maintenance, you can do it on the secondary as well, there is no issue. And any of the secondaries, right? So since you have multiple secondaries, so one of the secondaries you can do, and other secondaries would be available. So if there is any issues with the primary, it will fail over to the available secondary replica, right? So high availability clusterings, you can have that. And mirroring, like always on, you will have that because you have multiple secondaries, right? So you'll have multiple secondaries. And if you want to do a maintenance, right? We will talk about the maintenance or patches later, and I'll show you that as well. So we always do it on the secondary, not on the primary. Which secondary? Preferably will be on the asynchronous. Then we'll have to do it on the other secondaries. Once secondary is completed, then you can just trigger a failover from here to here, and you can have this as a primary, this as secondary, and apply the whatever maintenance here. That is how you will maintain a high availability, and that is the reason that we have this 99.999 high availability. But this is just a based on Microsoft um, internals or Microsoft books online. This won't be maintained. So just to highlight, right? So we will not have this 99.999 percentage always, right? It all depends on the the issue and the time, right? So these are all that we have in always on, right? So and in always on, um, okay, so we will talk that, but in always on, we have some enhancements with respect to the health detection, right? So we will talk that in a separate discussion, but you have a health detection, right? So for example, the nodes are healthy or not, or if the data is replicating or not. So we will have that, so if primary is always healthy or not, primary is healthy or not. So everything will be checking more thoroughly or more rigorously. It will validate if the always on is healthy or not, right? Starting from 2012, we have some health detection, high health detection mechanism, right? So high health detection mechanism, for example, SP underscore server, SP server diagnostics. Starting from 2012, we have this something called SP underscore server diagnostics. We will discuss that later. And we have this something called lease. We have something called health check, right? Lease and health check. So we will discuss all this in a separate discussion altogether. Okay, so we will have. Okay, so earlier versions, especially with the failover cluster, we use it to have is alive, looks alive, right? So this also we will talk. So I just say a difference. I'm making a note. I'm not discussing anything detail because we have detailed discussion on this is alive, looks alive as well, like how this works, is alive and looks alive, and how what is this ASP underscore server diagnostics, and what improvement that we have starting from 2012, Windows or SQL, whatever. So starting from 2012, what are the enhancements that we have, right? So we will have a detailed discussion on this, right? So these are all we have for clustering. So we have for, so always on, the difference that we have, the primary and the secondary. Now, let's understand a few concepts, right? So let's see. Okay, let's understand the concept of so health detection in always in clustering, right? So we will let's discuss that. Any points that I missed or anything you feel that like so we'll have to add for always on. We almost added, but anything that you aware and I have not added. But yeah, again, like you'll have multiple so enhancements. We will talk that later with respect to always on. These are the high level from day one, that is 2012 till today. So we have this. So along with the version of the SQL Server, we have multiple enhancements, right? So we'll have multiple enhancements, right? We will talk about the quorum, Anu. So we will talk about the quorum. Quorum is required for anything that it matters. Okay, let's talk about the quorum. We will talk that health detection later. Okay. So what we are always talking about the high availability, right? So we are talking about the high availability, right? So with respect to database mirroring or fellow cluster, DB mirroring, cluster, always. These three only suppose automatic failover, right? How this automatic failover happens, right? What is the mechanism that we require automatic failover, right? So we require a database mirroring, failover cluster, and always on. So except failover cluster, database mirroring and always on uses a standalone SQL server. Standalone as in, let's say you have two instances, you have two servers. You'll have instance one. On second, I'll make a note here. In instance one and instance two, right? You'll have two instances here. So instance one and instance two, two instances that you'll have. And this one you will install as a standalone. And here also you will install as a standalone SQL instance. And on top of that, you will configure some layer. Either it could be a database mirroring or it could be a always on top of this, right? But in the failover cluster, while so in the failover cluster, while installing the SQL instance, that self you will install as a failover cluster, SQL failover cluster. So it is just a you can consider that okay, so whatever, like I don't want to take any bad examples, but yeah. So if you have this as a SQL instance and you are adding this as a one connector, you can consider that, right? So you can consider that you are using as a connector, right? Let's say, for example, I mean, just a maybe one simple example. Let's say you have two monitors. Consider that you have two monitors, but this might not be a ideal example, but let's consider two monitors that you have, and two monitors are connected to one CPU, right? So two monitors are working and connected to one CPU, right? The same thing happens. I mean, same concept kind of thing, right? This one, server one and server two. These two servers are connected to one storage, right? At any point of time, wherever this is hosted, wherever, if this is primary or this is secondary, right? These are all just a connectors again. So the primary and secondary, whatever secondaries that we have, is just a connectors. But wherever it is maintaining is the matter, right? It is just a connector that we will have, and this one maintain the host, or this is the host, for example, right? So if this is the host, then you'll have this here. The disk is hosted on this. If this is the host, right? So failover happens and this become host, then it will have this disk added to this particular host.
Chandu, sorry to interrupt. So is it shared or something we cannot see the changes on the screen?
You cannot see the changes. I think you cannot see. Others, you are able to see the screen?
Yes, able to see.
I mean to see, guys, what screen you are able to see? DB mirroring, FCA, just arrow, always on, like that. That screen only you are able to see.
Like that.
Yeah, that only you are able to see. The servers and all we cannot see.
You cannot see the right side?
Yeah,
No,
yeah.
Also
We,
able to see the right side.
we got it now. I got it now. I got it.
I think
Thank
your
you.
network is slow.
Yeah, yeah. Sorry for that. Thank you.
Sure. No problem. Maybe I put it here. So maybe the reason you are not looking at the end. Okay. So I just mentioned here the reason that I can make a note here. Okay. So you have this cluster and you will have this server 1, server 2, like whatever the CPU. So this CPU, wherever it is, I mean, so sorry, it's CPU, just I take an example, but you can consider this as a storage, right? You'll have a hard disk storage. This storage cannot be hanging it between, I mean, hanging between these two. The storage also should be part of one of these two. Where this is part is depends on the host. Let's say the resources are hosted on this. This is your host. So the storage also will be plug in here. But if the host is changed, whatever reason, if failure happens, then storage also plug out from here and plug in here. Storage also will be changed here. This will become host or this will become primary, right? So this will happen. So this is the difference between standalone SQL and the cluster. So this is just a plugin. The reason I mentioned plugin, so plugin doesn't do anything, right? It's just a plugin whenever to maintain this whatever high availability, whatever, right? So if this is main hosted and if something goes wrong and it will fail over and this will be acting as a plugin to this, right? Just a connector. You can consider that. It is just a connector which will maintain the high availability feature, right? Now, we were talking about the failover, automatic failover and all. How automatic failover triggers, right? So how automatic failover triggers or where the host, I mean, where it maintains the, or how it failover happens, right? Let's say, for example, you have two nodes. If two nodes you have, if one node is down, how we to understand that I'll have to go to another node and, so failover should happen. So, right, how we understand there is another node and I'll have to go ahead and failover, right? That all depends on your quorum. That all depends on your quorum. So what is that quorum? Quorum in general terminology, right? So quorum in general terminology is the majority. Is the majority, right? So what is majority? Let's say, for example, take any example, let's say elections, right? Either it can be anywhere, like it is an election is the common word, right? Elections. Let's say elections. Someone has to win and someone has to lose in the election, right? How that happens? Let's say, for example, 100 members committee, they cast for vote, they cast their votes, right? If they go for votes and let's say, for example, 50 are party one or one party, like, so team one, team A, 50 team B. If you ask, or if I ask this question, which team wins the election? Which team wins the election? There is no guarantee. One of the team would win, right? So there is no guarantee that one of the team would win. So this can win potentially, or this can lose because there is no majority, right? That is where becomes majority with, right? Let's say first party or first team, team A, have 51 votes. Team B, 49 votes. Right? So if team A 51 and team B 49, this one is the majority or the 2 is the majority. Right? So with this majority, it forms the quorum. So based on the majority, forms the quorum. Quorum is nothing but majority. Right? It forms the quorum and whatever, like, so they will take over. Right? So this is what the quorum means. Right? So quorum is nothing but the majority. Right? Wherever you have the more number of votes, that majority goes towards. Right? So if you talk about the quorum in terms of database mirroring. So we talked about database mirroring, right? Can anyone tell me how failover happens? Automatic failover happens? I have two nodes. Principal, mirror. Right? So how failover happens if I have two nodes? Would it maintain the quorum? Would it maintain the majority?
For single, it's not needed, I guess, but maybe more than one secondary server at that time. Is it so?
Talking about the mirroring. Can we have more than one secondary in mirroring?
Oh no, mirroring, it's only one
Yeah.
to one.
Let's talk about the mirroring. So let's say you have primary, principal, and witness. Sorry, principal and mirror. Right? So if you have principal and mirror, so how the failover, like which one has the majority? Let's say, for example, the primary is down. Automatic failover would happen or no? This is a high safety I configured.
Yes.
How?
See, if one is down, automatically the second will get.
How?
I mean, it.
How? That's what I mentioned here. You have two, 100%,
Witness,
50-50. If these
witness,
50 is down, so there is no guarantee that this will make a form a quorum, right? The same thing. You have two nodes and one goes down. So how other will take over? You should have a majority. What is that majority? So if there is no majority, you will not have the, so it cannot form the quorum. So
but
what is the
here
majority for?
mirroring, we have this witness server, right?
Hmm.
So the witness server, with the help of that witness server, it will get automatic routed to the mirror server.
Yes. That's what it is, right? Witness is used, witness will help for automatic failover, right? Witness helps with automatic failover. What this witness acts as is one vote. Witness acts as one vote. So you have three servers will be connected each other, right? So witness also will be connected each other. While configuring database mirroring, it asks you, do you have a witness, right? If you select witness, witness also you'll have to select. So witness is nothing but a separate, so world itself, right? It is just a SQL instance, another SQL instance that you'll have to add to the database mirroring. So it acts as another vote, right? This will be one vote, this another second vote, this will be a third vote, right? You'll have three votes here. If primary is down, it will have the majority, 2 and 3. You have a majority, 1 plus 1, 2. You have a two nodes, two votes. You can consider that. Then if you have a two votes, then automatic failover triggers because it forms the quorum. Mirror server forms the quorum and it will become primary. See, same thing, right? So let's say, for example, you have 50 votes from one party and 50 votes from another party, right? I don't know from the US folks, like I think the same concept, right? From party, whatever, like votes and all. Let's consider that 50 votes from for one party and 50 another party, and one independent, someone like, so whoever like not part of these two, like someone independent, right? If that independent joins wherever it is, right? Let's say, for example, that independent person or the vote joins team A, party A, then this will form the quorum. If this independent goes to this will form the quorum, right? The same thing, this will maintain the witness, and wherever this is hosted, right? So primary, you'll have these 3 nodes. And if primary is down, then this will form a quorum with this. Like you can consider that witness as an independent, whereas independent as a like independent, candidate. I'm talking about, so in the election terminology, whatever that we call, right? So this will maintain the quorum and it will have the majority, right? It will have the majority so that it will become primary and it will become, even if it is disconnected, it will become primary, right? So what if it backs online? Primary backs online, it added to the overall quorum, but it is as it is like secondary and it will be primary. Automatic failover back will not be triggered, right? So if earlier primary came online, this acts as a secondary and joins to the mirror database, joins to the current primary, right? So like this, we will have the quorum configuration, quorum or the majority, right? But you will have to have the witness available here. So how about database mirroring? So how about the clustering that we have? Right. So I'll share that, like, so here just I'm just drawing in the pane the reason that you will understand better, right? So along with me. So we'll share the PPT and all. So don't worry about, so whatever we discussed.
Oh, Chandu,
Yes.
if I may understand you, what you're trying to say is that the A and B, if they are 50-50 are tied, then the weakness is what separates them. Is that what you're saying?
Sorry, witness what?
So if team A are 50 and team B are 50, that is a tie. Then the weakness is what separates them. Is that what you?
Correct.
Okay.
Correct.
Okay.
Let's say this is 50 and this is 50, and you don't have a witness at all.
It's gonna be tie.
It's gonna tie, and if it is down, the entire setup will be down, right?
Okay.
So it cannot form a quorum and it cannot bring the database online. If you have a witness, then it win the it wins the quorum and it forms the majority and brings the database online. Failover would happen.
Okay, I understand.
Right.
Thank you.
Yeah, sure. So the same concept, the reason I mentioned like votes and all, like this is same concept till today with AlwaysOn, right? So the same concept. I think there are something here and there, like, we have that Windows concepts like auto, whatever, like dynamic quorum and all, but the same concept happens till today. Anything. That's the reason. Just wanted to have this base clear so that you will understand the other features going forward, right? So in the database, in the failover cluster, FCI, right? So in the failover cluster, I will show this failover cluster and AlwaysOn. So how to configure quorum and all. So here till today, just understand the concept, right? I will show you how to configure witness or how to configure the quorum, right? Let's consider, but not for database mirroring. Database mirroring is a different concept altogether. I can show you that failover clustering, not SQL failover clustering, like, so it will maintain. Okay. Before that, failover clustering, right? So we have two concepts for failover clustering. One is the SQL failover clustering. Second one is Windows failover clustering, FCI. SQL will inherit the feature from the Windows cluster. SQL failover cluster inherits the features from the Windows failover cluster. So what does it mean? You will have to have the window. So in SQL, to have this SQL failover cluster, right? To have the SQL failover cluster, you will have to have a Windows failover cluster, right? So to have the Windows failover cluster, right? Without Windows failover cluster, you cannot have the SQL cluster installed, right? So you cannot have SQL cluster installed without a Windows failover cluster feature, right? So you'll have to have Windows cluster to have the SQL cluster. That is, so just remember that you'll have to have Windows cluster. The
Yes.
reason we need, yeah,
Yeah, it's a base for the SQL cluster as well as AlwaysOn.
correct. SQL cluster. Base for the SQL cluster. Yeah, we will talk about the AlwaysOn, but yeah, AlwaysOn also we require a base for Windows cluster, and the reason we will talk, right? So this is the base. Now let's say whatever configurations we configure, right? At the Windows cluster level will be inherited to the SQL cluster or AlwaysOn. Like we'll talk about the cluster and let's go with SQL cluster. Whatever configurations, let's say Quorum we were talking, the Quorum configurations will be configured at the instance, at the cluster level, Windows cluster level. So if we configure the Quorum at the Windows cluster level, that will take over by the SQL cluster. That will maintain the SQL cluster. It will not take over, but it will maintain, it will inherits or it will use that feature by the SQL cluster. How? I'll tell you. What are the Quorum configurations that you have? What are the Quorum configurations we have, right? Or majority, what we call, right? Whatever Quorum configuration. So whatever the Quorum configurations that we have, right? So we have, or whatever majorities that we have first one in node majority, disk majority, file share witness, or disk majority or disk witness, whatever we call. So this also we call witness. See, so in the database mirroring, we use the same witness word, right? Here also we'll have this witness, file share witness, and no majority, right? So you don't have any majority at all, right? So this is very less people are using, right? We'll talk what are these. So node majority and disk majority, and we have something called file share witness and no majority, and we do have cloud witness. I think I need to check like from when this is enabled. I think this is from IS servers or something, but I'll see that. But you'll have this cloud witness as well, or later starting from 2016 or something that I will check. But yeah, these are the Quorum witness that you will have, right? These are the Quorum witness that you will have. It all depends on the number of nodes that we have in the cluster. Node is nothing but a individual server, individual missions, right? So 1, 2, 3, 4. Let's say this one. 4 nodes that I have, right? 4 nodes that I have, right? So this is what we call it as a virtual missions. Let's say each node is considered as a server, or each node is considered as a virtual machine. right? So now if I use this node majority, if I use the node majority, what happens? Based on the majority number of nodes, it will maintain the quorum, right? If I have the majority number of nodes or majority number of servers, I will maintain the quorum, right? So let's say, for example, I have 4. What is the majority here? It will be 3. So if you have 3 nodes, then only the majority comes under, right? Let's say, for example, I lost 2 nodes. I lost 2. So there is no majority because I selected node majority, right? So again, the same concept, right? We have 50-50, it's a tie, right? So there is no majority. If this is the case, the entire cluster would go down because there is no majority here, right? So there is no majority. This is gone and the entire cluster would go down, right? If you don't have a majority. This might help if it is a odd number of nodes. Let's say, for example, another node that you have. Even if you lost 2, you will maintain 3. But again, like that all depends. What if you lost 3? It cannot maintain with 2, right? It all depends, right? So you don't have you cannot have the node major. If you have a node majority, you will have to have a majority number of nodes available. Node is nothing but a cluster, a virtual machine or the server in the cluster. Okay, so cluster is nothing but the collection of servers as a cluster, right? Just a terminology that you can remember. So cluster is nothing but collection of virtual machines or the collection of resources or collection of nodes, whatever we call it as, right? This is what cluster is, right? So node majority, based on the majority number of nodes, you will maintain the cluster. And disk majority, what is disk majority is, one second. Disk majority. Let's say the same concept, you have 4 nodes, right? Whatever 4 nodes that I have, or whatever, it doesn't matter how many nodes, that is same concept. Let's say disk majority. Disk majority is nothing but you'll have to have 1 disk. That's it. If it is a cluster, you will have to have a cluster disk. What does it mean by cluster disk? In the cluster, you will have to have the disk available for all the nodes, right? So what does it mean? You will have to have a shared disk. Right? You'll have to have a shared disk to have this disk majority configuration. So if it is a shared, what does it mean? Right? So we were talking about SQL Failover cluster, right? So if it is shared, wherever it is hosted, wherever the primary server is hosted, this disk also will be hosted on the same node. Let's say this is your primary, this is your secondary, secondary, secondary. If it is primary, the disk also hosted here only. So what is the disadvantage? This one server have 2 votes here. Now, 2 votes. 1 vote is this node. Second vote is the disk, because this disk also hosted on the same server, right? If this gone, you lost 2 votes. You are with me, right? So this is the primary server. This is one server. And if it is a shared disk, the shared disk has to be hosted somewhere. Where it is hosted is nothing but shared disk should be available there. Where it is hosted depends on where it is primary. If this is primary, then 2 votes will be to this particular primary. And if this primary is down, you lost 2 votes. Again, the same concept. If this is down, these two nodes are down, you lost two votes. One vote for each node, one vote for the disk. So that is the disadvantage using disk majority and the node majority. Now you have no majority. No majority is nothing but like you don't have any majority. You are just leaving that without a quorum configuration, right? You are leaving as it is without a quorum configuration. The same thing as node majority, whatever it takes as, right? You will not have any majority. I'm not going to talk about it. All right, while showing that, I'll show that, like, the options that we have. We have this something called cloud witness. I think this is for IaaS servers. You can use the cloud witness. IaaS as in infrastructure as a server. We will talk that later. But cloud witness, where you can host the witness, right? So where the witness or the majority to extend towards cloud, right? What does it mean? Let's say you have 4 nodes. Again, whatever nodes that I have, doesn't matter, right? You have multiple nodes here. And you have a cloud witness somewhere here, right? So you have somewhere the cloud. Let's consider cloud witness. So you have a cloud witness. So what does it mean? In the whatever cloud it is, like AWS, Azure cloud, right? Especially Azure cloud. Let's say the witness is hosted in the cloud, right? So if you will have these 4 nodes along with one cloud witness. This is very good in terms of, so maintain the quorum. But you will not have for every on-prem and all, right? So you will have to have this IaaS server so that you will have the cloud witness, right? Let's say this is server 1. IaaS is nothing but installed on a Azure cloud. The VM installed on a Azure cloud, right? So that we will talk. You will have the virtual one. Like if you lose the 2 nodes, if you lost the 2 nodes, again, it will maintain the quorum with a cloud witness and you'll have 2 nodes. So it will maintain a quorum and forms the quorum and failover would happen, or it maintains the quorum, right? That would happen with the cloud witness. And another one is file share witness. So far, except cloud is the best. If you don't have a cloud witness, so far the file witness is the best one. The reason that is best is you will have a less expensive. Let's say, for example, I need to have this cloud witness. Cloud witness also you'll have a little expensive because you need to utilize that whatever the cloud provider feature to have this cloud witness. Or you have this node majority. You will have to have extra node to maintain the majority. It is an expensive because you'll have to have an additional node to configure this witness or whatever it is. And if you use this shared disk, you'll have to have a disk, and that is a drawback because it hosted on one of the nodes. File share witness is less expensive because just it is a file share, right? You don't need to have a different server or dedicated server for this file share. You can have any server which matters. Make sure that this server is communicated with one of these, this server, any server. You can consider any server, it matters within the domain. Right, we will talk about the domain later, but let's say you have the organization XYZ. Let's say you have an organization XYZ company, Microsoft, for example. And this all should be in the same network. So if that is the case, this server is not part of cluster. No need to part of cluster. No need to part of this cluster. It can be anywhere hosted within the same network. and you can have the file share on this server. File share is nothing but like, you create a folder and right click and share the folder. That is considered as a file share, right? I will show that configuration later, but you can use this file share to configure Quorum. You can use that file share to configure the Quorum. This will be considered as one vote. And these 4 will maintain 4 votes. Now, if these 2 is down, then you will have this majority votes, right? Then you will have this file share as one part, one vote, acting as one vote, and you will maintain the quorum for your cluster, right? So until and unless this file share, the network is disconnected or file share server is down or anything, you don't lose this vote, right? So you don't lose the vote for this, right? This is the advantage of using file share. So far is the best. If you use, you can use. So you can, it is very less expensive and comparatively any other solutions, file share is the best, where you can use that file share to configure the quorum. It will maintain the quorum for you, and you will have this majority with the help of file share witness, right? These are the witness that we have. So any questions? I'll stop here. Any questions that you have? Any questions that you have? So yesterday we were talking about SLA, SLO, right? So I will give you link, like, so maybe you can have that. You can just go through. I have a detailed mention, so it is my so channel, like, where I have updated. So I'll just give me a minute so that you can understand so whatever that we have. 1 second. Okay, you can copy the link so that you will read through and understand that concept, if that is the case, right? So where is that? I'm just sharing this URL here so that you will have that understanding. I think this is going directly to this, right? I shared this SLA SLO so that you will go through, and I have few other always on related as well so that you can go through. But yeah, we will, if you have any questions, we can discuss now. Otherwise, we are good for today and we'll connect next. Shanmuk, you have any? I'll stop the recording now.